quick how to use this welder. This is your on and off control. So you turn that on. This is your amperage control. So generally you should only have to touch this, but it's set to remote, meaning it's got a foot pedal. Right here, sometimes the pulsation's on and off. Don't touch any of these knobs. Down here you want to be start, because this welder here is set for continuous aluminum welding. So you can just take a look at some of these settings. See, DC electrode negative, we're on DC. This pulse time, we're on the percent of weld current. Looks like that's 29%. Or 19, something like that. It doesn't really matter. I usually have my pre-flow time at 5 seconds, and then you have your post-flow time right around the same at 5 seconds. I don't generally mess with the arc force, but you can kind of see there's the remote control plug-in, and then right up here it's on TIG welding. So you can kind of see that's the best setup. So right over here we have a nice sharpened tungsten. Usually I have it set back, so if you had a square, it'd be around a little bit more than 90 degrees sticking out. It depends if you need more to get in into a corner, but for something like this, it's not something that we're going to need. You can see right over here, it's very important when you go to TIG weld anything, this is mild steel, but that's fine, that you make sure you wrap all your corners right there. Usually what I do is I'll tack. You can see right here, I'll kind of tack on my corners. That way I'll weld this, weld this one, weld the back, and then weld the inside. Now to weld something like this on the inside, whether it's stainless or mild steel, it makes it a bit tricky. I can get a little trick for this is you get a piece of the filler rod, you bend it 90 degrees, and it'll lay in here, and I'll weld this way, and I'll be able to pull back on this with some filler rod, and then I'll flip it this way, do the same thing, and then start here and continue up to weld the last little bit here. I'll have a straight section and just pull it out there. So it's very important. Like you can see in the middle where it goes either direction, but that's half decent. The reason you have the post-flow and pre-flow is for stainless steel especially, before you start welding it'll turn gray if you don't have a pre-flow. So you can see if I press on the pedal, it'll run gas out before it starts to arc. So it'll run gas out for about 4 or 5 seconds, depending on what you have set it. And then even afterwards, when you're finished welding, when you pull off on the pedal, right here, when you pull off on the pedal, it'll keep flowing the gas, and that will keep your electrode free from oxidization where it turns gray. And then this will keep your weld colored where it looks a bit rainbowish, and you'll see that especially on stainless steel, and I'll show you that. When you're welding mild steel, generally we're using ER70S2, so this is a welding wire, and for something like this, I'm using a 1/8 rod down on the lower end, and then I'll use a 1/16 on the top with this butt weld, because I didn't prep it, so it doesn't have a place to sit. It'll sit too high if it's 1/8 rod. Now when you're welding something like stainless steel, generally all the rods we have are 316, and all our stainless steel is 304. So it just prevents us from having lower grade of stainless steel on it. When I go to TIG weld something or tack it, what I like to do is bump tack it. So I turn the pulsation off. So right here, I turn this off, and my amperage is a lot higher than I need to for welding it. And I'll come here, and usually you can bump tack without filler if you don't have a gap. especially if it's thicker. The other thing to keep in mind is that's about twice the welding amperage, so it's kind of hard to see on this machine, but you'll get a feel for it. And I'm gonna let it sit there for a second, so you can see it's nice and it's not discolored. We got the proper gas flow. Now this might be kind of tricky here, this gap, so I might just use a bit of filler rod. So I'm going to turn pulse back on, and I'm going to weld this. And what I like to do is I'll kind of generally drag my my porcelain tip across the top, so I'm not going, I'm not freehanding it and shaking. I have my arm pinned on the bottom here for the filler rod, pretty much just have the proper amount sticking out. We'll be covering like a lay wire technique. So to do this, like I generally like to have a nice amount of stick out, like I discussed in the beginning of the video. And you're gonna need a nice sharp tungsten. So right here, you want to go nice and quick, you want to be nice and tight to it. And when you're done, make sure you don't pull away. So if it goes dark gray or a flat matte gray, it's not going to clean up. You want to try to keep it with this rainbow color. This would be fine. If you weren't using a Surfox machine and you're just doing something quick, now's the time while it's still kind of warm to hit it with a stainless steel brush, and that usually does a really good job cleaning it up. If you let it wait to cool down, it'll actually be harder to clean up. So that's another little trick there. I'm going to show you a portion of the weld that isn't, that won't be able to get cleaned up when the chromium gets burnt. So if I pull away right away, I have it running pretty hot. If I pull away without that, without the gas on there, you can see it goes gray, and that's not going to get cleaned up. So right off the bat, you're going to have to grind that and do an abrasion. But that's where the chromium's all burnt. You brought it up. You didn't use the proper shielding gas, and if your welds are looking like that, then you have an issue. So to remove the tungsten from here, you loosen this top off. This gun isn't water cooled, and we're generally not running it at the heat where it needs to be. So sometimes this is a bit hot. You grab this, and if you can come in right here. Now this is powered on when the welder's on, so you really want it to be as tight where if you touch it against your skin, it's going to stick right in. So be mindful of that. This side here is for stainless steel. This side's for mild steel and stuff. Don't let it sit in one spot, because it'll end up cutting all these grooves in there and it destroys the wheel quick. But you can see if I just move it back and forth, that's all it takes. In summary, like when you're getting these and you got a pile of stuff to TIG weld and they're all the same, get set up with a process and a pattern. Try to get muscle memory down. Get a nice like I have a seat here, got my table fairly clean and organized. But what I want to do is make sure I'm comfortable and try to get in the rhythm. Make sure, you know, if I'm welding this first and then I come in here and I weld this and then I do this. So like you get a rhythm going. The other side of it too is think of efficiency. The nice thing with pulsation, like when you're pulsing on your weld, is you can weld a lot faster. You can be high-low. You can weld a lot faster, and you can put a lot more weld down quickly compared to not having that. So it isn't like it's a cheating thing. It's an advantage on a machine to do things efficiently. So if you're doing stuff like this and there's not a reason, like you need a reason to be essentially set up to not do pulse. There's just no way you can weld faster than using that. The other thing with let's say mild steel compared to stainless steel, mild steel you can do a pulse fusion where it'll look like a TIG weld, but it'll be all fused together, and that's really handy. It'll look like stacking diamonds, but it'll be fused, and that's really good. With mild steel, you can't fuse weld. It'll actually create porosity. So there's a coating on the rods that helps not create porosity. But when you're set up here, try to get set up with lay wire, where you're laying the wire down, you get your angle just right. I put a bit of pressure on this, and your arc is just wicking the molten wire into the puddle. And sometimes you got to adjust your torch angle and stuff like that. But if you have a nice sharp tip and you have the proper amperage set as well as a proper wire size, you just play with your angle and you can get that lay wire to work really nice where you're welding fairly quickly. It's worth mentioning mild steel. This mild steel's all been cleaned off. There's no mill scale on the inside and outside. And same thing with the stainless steel. It's been all wiped down. If there's any oil on it, it's going to create some. You're going to get contaminants in your weld, and you're not going to be able to clean it up properly.
So here's an arc shot, and when you're watching this, you can see the low and high pulsation of the pulse setting. This helps keep the heat down as well as making a wide fillet, and it allows you to kind of move a bit faster. You can kind of see the wicking where the filler rod is laying nice and shallow and it gets sucked into the weld.
Right here is an example, like the tip has just been touched a couple times on the molten metal, and it's just not that sharp. So this is going to require resharpening. I'm just going to pump this so you can see what rating we're at. We're about 30 cubic feet per hour on this scale. It's worth mentioning the two types of tungstens we use. This blue is lanthanated. These are 1/8. That's generally for the aluminum welding. This is E3. This is similar to red, so you can use that for just normal stainless steel, mild steel welding. So you might be wondering, how do you practice TIG welding? Usually what I tell people to do is get some 2x2 by 1/8 wall thickness, some 10 gauge stainless steel, and weld it. And I'm going to tell you, if you can weld 8 of these, I'm going to go about doing it right now. If you can weld 8 of these consistently and they look the same, that's pretty much what we're requiring. It'll be like this.